This video is about stretching function equations and their graphs. So we're going to think about two different kinds of actions there. We're going to think about a vertical stretch and a horizontal stretch. And let's think about the action that that has on the equation, the effect on f. So if you're going to stretch vertical, let's stretch vertically by a factor of 2. So imagine stretching by 2. Since you're vertically stretching, vertical has to do with the output. So it's on the outside. So output has to do with vertical. So we're going to do something on the outside. Now, if you think every output is going to be twice as big, you're exactly right. So here's a nice little function down here. You could graph those points if you wanted to. Let's see, at -1, we're at 3, then 0, then 3. So these might be 3 points on, say, the absolute value of 3x function. Okay, what would happen if you put a 2f of x here? You'd have 6, 0, 6. And you could sort of see what that would do is take you through those 3 dots, and you'd have stretched this vertically, okay? Well, what about a horizontal stretch? So a horizontal stretch has to do with the inputs. The inputs are graphed horizontally. So let's do a horizontal stretch, let's say, by 3. So this has to do with the inputs. So it should have something to do with the inside. But let's think about this. You might say, well, gee, I'm going to put a 3 on the inside. Well, that's not quite what needs to happen here. In fact, if you're going to stretch horizontally by 3, you actually have to put a 1/3 on the inside, as we'll see right here. So now, since you're working on the inside, you can't put another column here. What you actually have to do is you have to say, well, what would happen if I put 1/3 x inside here? So if 1/3 x was -1, then f of 1/3 x would be 3. If 1/3 x was 0, f of 1/3 x would be 0. So then you've got to work backwards to the input. Well, if 1/3 x is -1, I guess x had to be -3. Let's double check. 1/3 times -3 is in fact -1. How do you get 0 here? Well, if x is 0, 1/3 of x is also 0. And if x is 3, then 1/3 of x is 1. Okay, so these are the ordered pairs that come out by this horizontal stretch. So think about what that does. Now we've got the point -3, 3. So we get it out to -3. We've got the point 0, 0. And then we've got the point 3, 3. Can you see it's actually the 1/3 in there that stretches this horizontally like we'd like to? Now we can do that with the equation here. Let's see. Let's go ahead and stretch this vertically by 4. Okay. Well, vertical is actually the easy one to do. So that's 4h of t, or you could write that as 4 times 2 over t squared minus 1 minus the square root of 2t. Now you could distribute that 4 to both terms, but this is perfectly correct like that. Now let's think about horizontally by 1/2. Now a horizontal stretch by 1/2, many people would actually call a compression. So if you make it 1/2 as wide, that's actually compressing it, right? But how would you do that? Well, a horizontal would put the reciprocal of this number in here. So if you're stretching it by 1/2, what's 1 over 1/2? Well, it's 2. So I'm going to take this, I'm going to have h of 2t, which equals, now I'm going to take 2t and put it in for t there. So 2 over 2t squared minus 1 minus the square root. You could write 2 times 2t. I'll go ahead and write 4t. So that's how you do a horizontal compression by 2, or as I'm writing it here, a horizontal stretch by 1/2. Well, the graph, just as long as you keep in mind what's actually meant by these terms, it should be pretty simple. Let's do a vertical stretch by, let's do 4 again. Okay, so what do I do here? Well, I don't change the horizontal position, but I take every y coordinate and I make it 4 times the magnitude. So this is -3, -1. Now I'm at -3, -4. I won't write all the coordinates, but you can see what's happening there. This point is -1, 0. It'll stay put. This is 0, 2. It'll be somewhere up here at, oops, and that's an open dot, 0, 8. And this point was at 0, 1, so it's now at 0, 4. This is at 2, -1, let's say. So we're now at 2, -4. That's what your graph looks like. Can you notice how the graph is stretched? It still goes through the same points on the x-axis. Okay, let's do one last one here, then we'll be done. How about a horizontal stretch by 3? Okay, a horizontal stretch by 3, starting again with these. That's going to leave the outputs unchanged, but the inputs will be changed. Oh my, 3. So that's maybe a little large for my picture. Let's go 2, just so I don't have to go so far out. Here's -3. This will come out to -6. This is at -1, so it'll come out to -2. This, the x coordinate is at 0, so those will be unchanged. Here the x coordinate is 2, so it'll be out here at 4. So notice the outputs haven't changed, the inputs have though. So now you have a horizontal stretch, and that's what your graph looks like. So that's with the equation and with the graph how you're going to do stretching.